Hello students, today in this class we shall discuss uniform circular motion. What is circular motion, how it occurs, what is the reason behind it, who is responsible for it, etc. Okay, so before going through it in detail, let us first know what is circular motion. If a body circulates around a particular point, then that is circular motion. Very simple thing. What is uniform circular motion? If speed of the particle at every point on the circle is same, velocity at this point is, let it be v1, velocity at this point, let it be v2, and I have assumed that the body is circulating in counterclockwise sense. This is v3 and this is v4. I have chosen 4 different points. If at all these points the magnitudes of these velocity vectors, that is v1, v2, v3, v4 are same, if the magnitudes of v1, v2, v3, v4 are same, then the motion is called uniform circular motion. Otherwise it will be non-uniform circular motion. So very simple. So if it is uniform circular motion, I can simply assume v1 magnitude is equal to v2 magnitude is equal to v3 magnitude is equal to v4 magnitude is equal to v. Let all the magnitudes be v. Okay. Now this is our center O and this is our radius vector R. Okay. Now let us come to the real topic, how circular motion happens. So before going through in detail, for the uniform circular motion we have assumed already all these values are v, so I will simply write v, this is v, this is also v, this is also v, but I cannot write it v vector anymore, because if I write here v vector, I also write here v vector, then these two vectors are not equal because their direction are different. So I cannot assign vector sign here. I can only write speed is v here. This is speed v and this one is also speed v. At every position speed is constant, but directions are different. Now let us first consider some things that we should know before going through in detail. What is angular displacement? That is theta, or del theta you can also say, del theta. Okay. What is angular displacement? Suppose the body initially was here, now it circulates, means after some time it will go to this point. Now this is origin, that means this is initial position vector of the body, so let it be r1. This is next position, after some time let it be position vector r2. Now angle subtended by the body, let it be del theta. Del theta. Then from this point to this point the body has been displaced. There are two displacements here. One is linear displacement, that is straight line joining between these 2 points, and another is angle subtended by the body at the center. What is the relationship between these two? we already know that arc length is angle into radius. Arc length is angle into radius. What is arc length here? Let us suppose this displacement is very small. From this point to this point, the linear displacement is very small. What do you write? Denote the displacement. Displacement is our, okay, arc length is displacement, so I can write it as del r, linear displacement. What is angle? Angle is subtended is del theta. I don't know whether del theta is a vector or a scalar, I don't know. So I will simply write del theta. Then radius into radius. If displacement is small, then R1, R2 can be considered one vector. If this is very small, small means what? Del theta tends to 0. So if del theta tends to 0, then R1 is nearly equal to R2. Okay. Then radius, I can choose any radius, that is R. Okay, but R is a vector, I can write it. Now the question is, del R is a vector, R is a vector. If del theta is a scalar, then del R and R should have the same direction, because scalar multiplied with a vector does not change the direction of the vector. So del R direction should be equal to R direction. Now let us check. Del R is vertically upward. R is in x-axis, you can say. That means the angle between them is 90 degrees. So the direction is not same. That means this relationship is not exactly accurate, you can say. So it is not perfect. You should change something. But this relationship is okay. It is true. That means from this we have derived this. Then what is wrong with this expression? So if I put here a vector sign? If del theta is a vector, then what happens? We shall see. If del theta is a vector, then this is a cross product. We cannot simply multiply here, because two vectors can be multiplied in two ways. One is dot product, another one is cross product. So here cross product, you have to take cross product because this is a vector. If it is a dot, then it must have to be a scalar. Since this is a vector, you have to put here cross mark. Then let us check what is the direction of del theta and R. Now the question is, what is the direction of del theta first? In what direction the del theta is indicating? So it is circulating like this. That means you cannot say vector is like this. No. It is continuously changing, and a vector cannot continuously change its direction. If del theta is counterclockwise or clockwise, there are only two ways we can measure it, theta, either in clockwise sense or in counterclockwise sense. If the body is moving in counterclockwise sense, then let the del theta vector be upward, and if the body is moving clockwise sense, let the del theta vector be into the board. Two senses of movement, so there are two directions. If it is upward, then counterclockwise. If it is downward, then it is clockwise. Very simple. So now in my example, the body is moving in counterclockwise sense. So this marker is pointing the direction of del theta. Now theta is along this path. Then what is the direction of del theta cross R? To find the direction of del theta cross product, very simple way, put the screwdriver here, rotate it from del theta to r. So I have to rotate like this, that means clockwise sense. If you rotate it clockwise sense, screw will go up. Yes or no? If screw goes up, that should be the direction of del theta cross r. Now this is the direction of del r or not? It is same as del r direction. That means this relationship is now complete. So this is the relationship between linear displacement and angular displacement. Okay. So this is the very first relationship towards our circular motion concept. Then you have to go for angular velocity. We have already got displacement, then you have to go for velocity. So how to derive it? Angular velocity is denoted as omega. So I will start from that very recent relationship that we have already derived. Del r is equal to del theta cross r. Now what is the angular velocity? This is what is linear velocity? Linear velocity is rate of change of linear position. Similarly, rate of change of angular position is angular velocity, or displacement by time is velocity. Similarly, angular displacement by time is angular velocity. Very simple. So I will divide del t on both sides. The time taken by the body to go from this point to this point is del t. So this will be my linear displacement by time. This is angular velocity by time. So this will be equal to, this is nothing but linear velocity. Linear velocity. This is my angular velocity. This is my radius vector. So this is the new relationship. This is my linear velocity. This is my angular velocity. Okay. Omega is a vector. Again, what is the direction of omega? We already know v is along the displacement, yes or no? So now I will write here v. We have already written here, so I will put a vector sign here because v is pointing in this direction. Now r is towards the east. Now what is the direction of omega? Again, since we know velocity is always along the displacement, linear velocity is in this direction, means linear velocity is also in this direction. Similarly, angular displacement is in this direction, means angular velocity must be in this direction. Yes or no? Displacement and velocity must have the same direction. So del theta vector, we already know that it is away from the board. This is angular displacement with direction. So omega is also in this particular direction. Why not? Let us check from this relationship also. If this is omega, this is r, then omega cross r will be pointing upward and v is pointing upward. So v vector is here. So v is equal to omega cross r. Very simple. Okay. Now let us find out what is the magnitudes of both these vectors. Okay. So in this class we shall only discuss angular displacement and angular velocity. In the next class we shall discuss rest part of the circular motion. So what are the magnitudes? First, magnitudes of our first we derived del theta del r is equal to del theta cross r. Del theta is upward, r is in the x-axis, so angle between them is 90 degree. If I write del r, that is linear displacement, as s, which I can write s is equal to, I can write del theta vector as theta vector also, cross r. I am using simple variables. Angle between them is nothing but theta r sine 90 degree. Sine 90 degree, what is its direction? Along the displacement, that is in this direction. So I will put more sign everywhere because I am finding the magnitude. This implies s is equal to theta r sine 90 is 1. So this is my relationship. S is equal to theta into r. This is first. This is in terms of magnitudes. Similarly, what is this relationship in terms of their magnitudes? Now again, v is along y-axis, r is along x-axis, and omega is along the z-axis. That means everyone is 90 degree to each other. This implies v is equal to omega r sine of 90 degree. This implies v is equal to omega r. So this is in terms of magnitude. So in the next class we shall discuss angular acceleration and its relationship with linear acceleration. Then we shall go for the real reason behind the circular motion. Okay, thank you.